Have you ever looked up at the night sky and wondered, could a colossal asteroid really put an end to everything we know? As dramatic headlines scream about a massive asteroid on a collision course with Earth, or ominously refer to a doomsday rock that could end humanity, we find ourselves caught between deep-seated fears and hard scientific facts. Today, we journey into this realm of myth versus data. We will explore the origins of these fears, unpack sensational rumors that have spread like wildfire, and ultimately reveal the robust science and dedicated planetary defense measures that stand ready to protect our world. Our story begins millions of years ago, when a giant asteroid fundamentally reshaped life on Earth. 66 million years past, this cosmic traveler struck our planet with devastating force, wiping out the dinosaurs and forever altering the course of evolution. That singular event imprinted on our collective imagination a deep sense of vulnerability, a belief that one wayward rock from space could bring unimaginable destruction. Over time, movies and media have magnified this notion, transforming these celestial objects into symbols of impending doom, even as the reality of asteroid impacts is far more nuanced. In recent years, the internet has amplified these fears further. Rumors emerged about an asteroid with a striking 72% chance of hitting Earth in 2038, a number that many mistakenly thought was based on official NASA data. In truth, that figure originated from simulation exercises designed to prepare us for potential emergencies, akin to fire drills in a school, crafted to test responses, not to predict catastrophe. This mix-up of cautionary practice with sensationalized news has sparked widespread panic, feeding into an atmosphere where every headline beckons with doomsday imagery. Yet as we sift through the noise of sensational claims, a more measured and scientifically grounded narrative begins to emerge. Established space agencies like NASA and the European Space Agency, ESA, vigilantly monitor thousands of near-Earth objects using powerful telescopes. Today, no known asteroid poses an imminent, catastrophic threat to our planet. Should an object of genuine danger be discovered, rest assured, space agencies worldwide are committed to transparency, ensuring that accurate information reaches the public immediately. It is important here to emphasize a remarkable breakthrough in our efforts to safeguard the Earth: the successful execution of NASA's Double Asteroid Redirection Test, or DART mission, in 2021. This mission was not a plot out of science fiction, but a tangible demonstration of planetary defense in action. In a historic moment, scientists and engineers deliberately altered the trajectory of the asteroid Dimorphos by crashing a spacecraft into it. Remarkably, this kinetic impact reduced Dimorphos' orbital period by a staggering 32 minutes, far exceeding what scientists had hoped for. The success of the DART mission has cemented our confidence in our ability to nudge a potentially hazardous asteroid off course, mitigating future risks. Imagine this. On April 13, 2029, asteroid Apophis will make a breathtaking pass by Earth, coming within approximately 20,000 miles of our planet, closer than many geosynchronous satellites orbit overhead. Early estimates once suggested a 2.7% chance of impact during its close encounter. However, subsequent observations have laid such fears to rest. Apophis, while a subject of intense study due to its proximity, now presents no significant threat. Instead, it offers an unprecedented opportunity. Scientists eagerly await this event, anticipating that the unique close approach will yield invaluable data about near-Earth objects and refine our planetary defense strategies. Amid these awe-inspiring facts, it is easy to see how myths have taken root in our cultural consciousness. The media often frames these scenarios with dramatic language and eye-catching numbers, blurring the line between careful scientific inquiry and sensationalism. The stark contrast between reported rumors and the rigorous evidence gathered by scientists forms the crux of the conflict we face. The uneasy tension between fear driven by misinformation and the reassurance provided by measured, credible research. Over the course of our narrative, we now dive deeper into this tension. When faced with news that evokes images of a colossal rock hurtling toward Earth, it is natural for emotions to surge: fear, anxiety, and a sense of helplessness. Yet, as we peel back the layers of this narrative, we discover that our planet has more protective measures than we might have imagined. Modern technology and international collaboration have ushered in a new era of planetary defense. agencies run regular simulation exercises, comparable to fire drills, that test our capacity to respond effectively to potential celestial threats. Crucially, these exercises are designed not to alarm but to prepare us, ensuring that every possible step is taken if an actual threat ever emerges. Throughout history, natural events have been subject to human interpretation wrapped with storytelling. Early humans viewed thunderstorms as angry deities and eclipses as ominous warnings. In our modern era, asteroids have similarly been shrouded in myth. The truth, however, is firmly rooted in scientific method and evidence. Present-day researchers rely on precise calculations, continuous monitoring, and international data sharing to map the trajectories of celestial objects. This rigorous approach allows us to separate fact from fiction, spotlighting not only the potential risks, but also the profound capabilities of human ingenuity and collaboration in mitigating those risks. Consider the moment when a simulation exercise using a hypothetical asteroid scenario was misconstrued as an imminent threat. The number, a 72% chance of impact, swiftly circulated online, driven not by fact but by a misinterpretation of a drill's parameters. Such moments underscore the importance of context in understanding scientific data. They remind us that while simulations are indispensable tools for improving our readiness, they are not forecasts of impending disaster but rather stress tests aiming to refine our responses. This delicate interplay between myth and science is what makes our exploration so compelling. It invites us to ask, how do we balance sensational claims with a clear-eyed assessment of our capabilities? The answer lies in embracing the well-documented achievements of our space programs. Missions like DART remind us that our collective scientific endeavor is not only about predicting outcomes, but about actively shaping our future. Every technological leap, every refined measurement, advances our understanding and fortifies our defenses against the unpredictable whims of the cosmos. Looking back on the epoch of dinosaur extinction, we are reminded of the raw power of nature and the tremendous impact one event can have. Yet, today, armed with knowledge and advanced technology, we approach the cosmos with a proactive mindset. The story of Apophis in 2029 is not one of foreboding fate, but an inspiring chapter in our ongoing quest for understanding. It is a celebration of scientific progress, where the threat has been recontextualized into a grand opportunity for discovery and learning. During Apophis Close Pass, we will witness a celestial event that not only provides awe-inspiring visuals, but also enriches our scientific archives, helping to hone our techniques in detecting and deflecting potential hazards. Not every rock that passes near our planet carries the weight of myth and dread. Instead, through careful observation and meticulous calculation, scientists have determined that the majority of near-Earth objects are of little consequence. They become silent messengers of the cosmos, offering insights into the very fabric of our solar system. The heroes in this story are the dedicated researchers, engineers, and space explorers whose persistent work transforms potential catastrophe into calculated caution. As the narrative unfolds, we see that our journey is one of empowerment through education. The initial shock induced by sensational headlines gradually gives way to the calm assurance of scientific clarity. This transition, from panic to knowledge, mirrors the evolution of our own understanding as we learn to trust in data and empirical evidence over unfounded rumors. In the quiet moments after each sensational claim, it is the patient, diligent work of the scientific community that shines through. The story of our planetary defense is not one of inevitability, but of possibility. It is a tale of how humanity collectively harnesses ingenuity to overcome even the most daunting challenges. Every telescope pointed toward the stars, every simulation run and every piece of data meticulously analyzed, stands as a testament to our unyielding determination to protect our planet. In closing, the adventure of exploring our cosmic neighborhood is as much about debunking myths as it is about celebrating our achievements. The myths surrounding asteroids, while evocative and steeped in dramatic history, must not overshadow the remarkable successes of modern science. Our exploration into the science behind asteroid threats shows that while the cosmos may be full of unknowns, it is also a field of endless opportunity for growth, discovery, and innovation. So, as we stand beneath the vast star-filled sky, let us replace fear with understanding. Let us recognize that sensational claims often mask a wealth of knowledge acquired through rigorous scientific inquiry. The dangers of space are not to be dismissed, but neither are they the impending harbingers of doom as sometimes portrayed in popular media. Each near miss and every calculated maneuver by space agencies around the globe underscore a profound truth. We are far more capable than our myths suggest. By embracing accurate, thought-provoking science, we empower ourselves to look beyond the superficial terror and focus on solutions. Remember, every scientific instrument and every daring mission to alter an asteroid's path reinforces our resilience and highlights our ability to transform fear into progress. The future of planetary defense is a story of hope, a narrative that champions preparedness over panic and innovation over inertia. Let the tale of our cosmic neighbors serve as a reminder that knowledge is our best defense. Stay informed about near-Earth objects and planetary defense initiatives by following updates from NASA and other space agencies. Understanding the science behind asteroid tracking and deflection can help dispel myths and provide a realistic perspective on our planet's safety.